Welcome to our new class. Today I teach you Higher Mathematics exercise 1.1. Our topic name set and function. Set and function. Actually exercise 1.1 is related to set. I think you all know. This is the pen. So if we take three pen, then it's the set of pen. And if we take the duster, so this is the set of duster. So in the similar way, if we take the book, the set of book, set of pen, set of pencil, these are the sets. Now follow the board. A collection of some well-defined objects called set. Collection of some well-defined objects is called set. Who invented set? George Cantor, 1845 to 1918. George Cantor. Who invented set? George Cantor. First introduced the notation of set. The set is expressed by the symbol in second bracket. I think we all know the bracket. This bracket, we have to use second bracket as a notation of set. Example, the set A, B, C is, we have to keep it in a bracket A, comma, B, comma, C. These are the elements of set. How many methods of set? There are two methods. One is tabular method, another is set builder method. So how many methods? Two methods. One is tabular method. I think we all know table. 2 to the 4, 2 3 the 6, 3 to the 6, 3 3 is the 9. These are the table. That means 1, 2, 3. This type. These are the tabular method. Okay. Now then set builder method. So if we want to build a bridge, build a building, then we have to take lots of bricks, then concrete, cement, etc. Okay. So in set builder method, we can see this type of symbol, x such that x is an integer number, x square less than 10. So you can see greater than, you can see less than. That means you can see brief type of using symbol type. Okay, symbolic. That this is clear, visible. This is visible. But in set builder method, you have to find out the set. So we will learn today set. Already we have learned about set. Then finite set, infinite set, empty set, subset, proper subset, superset, equal set, and equivalent set. Okay, so we will learn all definitions, and we will discuss universal set, and we'll do some maths about union, intersection, that complement. Okay, then we'll discuss the Venn diagram, then we'll start a proposition. Okay, so let's come to the point. Follow the board. Already we have learned what is called set and who invented set. Now lots of definition you have to know. You have to do main focus on your basic development about your mathematics. Okay, this is the first topic and first chapter and foundation chapter of set in higher mathematics. Set also you can see in general mathematics, that means mathematics. Okay, and already you have got some information about set in class 8 also. So let's come to the point. Again we have to learn some definition about set. So please follow the board. Finite set. Fine. That means elements are fixed. You can see the board. A set with limited number of elements is called a finite set. Finite set. You can see a equal to 1, 2, 3 up to 10. That means number of elements fixed number of elements. So this is the finite set and infinite set. Infinite set, a set with unlimited number of elements is called infinite set. Elements are not fixed. You can see here is 1, 2, 3 here is not fixation. Okay, you cannot see any fixed number of set. So this is infinite. Now we have to know the empty set. Empty, that means blank. So a set which has no element is called a empty set. Empty set denoted by this symbol or this symbol. You can see in your book also this symbol. Okay, so be careful. So empty set, that means no element. Now subset, an important part of this exercise, subset. If A and B are two sets, A will be subset of B. A will be the subset of B. That means jela and upojela. Okay, jela and upojela. So if A and B are sets, A will be the subset of B. A will be the subset of B. If and only if every elements of A are elements of B, that means all elements will be included in B. So you can see the example. If you follow the example, then it will be clear. If A equal to 1, 2, 3, A equal to 1, 2, 3, and B equal to 1, 2, 3, 4, 5, 6. So you can see here is 3 elements, 1, 2, and 3. You can see here is 1, 2, and 3. 1, 2, and 3. So 1, 2, and 3 belongs to B. 1, 2, 3, 3. If we find out in B, we can see A. Here is 1, 2, 3. Here is 1, 2, 3. So A is subset of B. This is the symbol of subset. You have to note some instruction. Every set is a subset of itself. Every set is a subset of itself. And empty set is a subset of every set. Empty set is a subset of every set. So when we solve the subset type maths, we have to use this symbol or this symbol. Be careful. Every empty set is a subset of every set. Empty set is a subset of every set, and every set is a subset of itself. Every set is a subset of itself, and we have to know the rules. If formula of 2 to the power n is the number of elements. Formula for subset is 2 to the power n. This is the formula of subset. Now we will to find out a subset. Okay, let's come to the board. The students, come to the point, find out the subset. So if you can see, if A equal to ABC, then subset of A equal to what? How many subset will come? We have to break it. Already we all know the rules of subset is 2 to the power n. 2 to the power n. N is the number of elements. Number of elements. Find out the elements here. Here is the element A, B, C. These are the elements. So how many elements you can see? 1, 2, 3. Number of elements 3. So if we find out the subset of A, then we will get number of subset 8. Why 8? Here is 3. Here is 3. Then 2 to the power 3. 2 to the power 3 equal to 8. We will get number of elements 3. So let's come to the board. A equal to this, subset of A are. Here is how many? 1, 2, 3. So if you can see the 3 elements, keep it in your mind in a technique. Here is how many elements here? Here is 3. That means 3, 2, 1. So every set is a subset of itself. Every set is a subset of itself. And empty set is a subset of every set. Okay? So empty set. So at first you have to write 3 elements. Then you have to take 2 elements. Then you have to take 1. Then you have to take 5. We will get number of elements 8. So follow. Subset of A are at first 3. What is it? 3, 2, 1 and 5. 3, 2, 1 and 5. 1, 2, 3. 3. 1, 2, 3. 3. Then 2. A, B. B, C. Then AC. A, B, B, C, AC. So what I say? 3, 2, 1. 3, 2, 1. Then empty set. 3, 2, 1. So 3. Then 1, 2, 1, 2, 1, 2. 3 and 2 completed. Then it will come 1 by 1. It will come 1 by 1. 1 by 1. 3. We've taken 3, then 2, 3, then 2, so we have learned the subset. Now you can count 1, 2, 3, 4, 5, 6, 7 and 8. So according to our definition, subset completed. Now we will do proper subset. Please follow the board. We will learn now proper subset. Okay, let's come to the point. Already we have learned the subset. Now we learn proper subset. So which one is the proper subset and what is the rules of proper subset? So please follow the board. You can see I have written already the definition. Proper subset. Few minutes ago we have learned subset. Now we learn proper subset. This is the difference between subset and proper subset. So follow the board. Any set is said to be a proper subset of another set B. Another set B. How many set? 2 set. If every element of A is also every element of B and there exists at least one element B. At least one element B which do not belongs to A. Which do not belongs to A. Which do not belongs to A. So set A is a proper subset of set B if there is at least one element in B not contained in A. not contained in A. Be careful. You can see here is A, B and C. How many elements? Here is 3 elements. So according to the definition, at least one element in B not contained in A. B element will not carry A. Okay? So you can see here is A, B and C. Here is A, B, C and D. A, B, C and D. So A is a proper subset of B. A is a proper subset of B. I think this is clear. Now we'll do a maths for the proper subset. So here is, I have written an example. Please follow. If P equal A, B, C. Before doing this, we have to know our rules. Few minutes ago, for subset, we have learned the rules 2 to the power n. This is the rules of subset. This is the rules of subset. And this is the rules of proper subset. Proper subset. Okay? So, I have written 2 examples. Please follow. If P equal to A, B, C. So, you can see subset of P are. Few minutes ago, I have been discussed 3 to 1. 3 to 1. So, the method of 3 to 1 is a technique. So, here is A, B, C. So, 3 A, B, C, then A, B, B, C, A, C. A, B, C and empty set. This is the subset. This is subset. So, subset completed. Now, proper subset. What I say? What is the rules of proper subset? 2 to the power n minus 1. You can see I have written the proper subset. Proper subset. Please follow. Just one element will be missing. One element will not be visible. So you can see here is ABC, but here is no ABC. I think you can see here is no ABC. I have started from AB, BC, AC, A, B and C. A, B and C. One element shortage. Okay? I think we are clear about subset and proper subset. Okay? Now we will learn again about set related symbol and set related some definition and Venn diagram also. Okay. Subsets, set of all the subsets. So here is power set of A, set of all the subsets. So at first you have to find out the subset of A. So solution. So short maths. So P of A, that means power set of A equal to, for set, when you solve the any maths about set, you have to use second bracket. Be careful. For every maths, set related maths, be careful. You have to use second bracket. Be careful. Subset. At first we have to find out subset. Subset of this. So subset of, here is how many elements? 1, 2, 3. 3 elements here. So 1, 2, 3. So 2 to the power 3 equal to, we will get number of elements are 8. Number of elements are 8. Let's come to the board. Here is 3 to 1. 2, 3, 5. Then you can remember this maths using ABC. ABC, AB, BC, AC. A, B, C. Then 5. Same way, this is A, B, C. So A, B, C. A, B, C. Then A, B. Replacing A, B. So this is A, this is B. So A, B, B, C. B, C. A, B, B, C and A, C. This is A and this is C. A, C. So A, B, C, A, B, B, C, A, C. Then A, B, C. A, B, C. Then how many elements? Count it. 1, 2, 3, 4, 5, 6, 7. But your total element will be 8. Then one empty set. You can use this or second bracket. Be careful. So here is, you have to start. What is the difference between subset and power set? Subset. If bracket is missing, then these are the subset. But for power set, you have to use at first the second bracket, then the last one will be the second bracket. Okay? All are subsets. All are subsets. Okay? Here is extra part is only here is starting a second bracket and last one is second bracket. Okay? I think you have got the power set. You have got the power set. Okay, let's come to the next part. Okay, let's come equal set. What is called equal set and equivalent set? So you can see the equal set. Equal, that means this pen equal to this pen. Elements are equal. Number of elements are equal. You can see if the elements of two sets are same. Two sets are same. Be careful. Now elements of two sets. Elements of two sets are same. That is called equal set. That is called equal set. You can see according to the example, here is A, B, C. Here is B, C and A. So A, B, C and B, C, A are same. So this is the equal set. But what is called equivalent set? So please follow equivalent set. What is called equivalent set? If two sets, how many sets have the same elements, they are said to be equivalent set. They are said to be equivalent set. Then they are denoted A equal to B, A equal to B, which is as like as a subset, A subset of B and B subset of A. We all know the Zilla and Upazilla system. For this reason, you can see here is A equal 3, 5 and 7. A equal 3, 5, 7. B equal this 5, 3, 3 and 7. Here is 3, 5, 7. So if we can see, here is 3 is repeated. 3 is repeated. So according to the set, we can say A equal to B. Again, another set we can see C equal 7, 7, 3 and 5, 5. Here is 7, 7 is double and 5, 5 is double. So if we follow A, we get here is 3, 5 and 7. So if we rearrange C, we will get 3, 5 and 7. Just order are same. So we can write A equal to B equal to C. A equal to B equal to C. If the order of elements in the sets are changed or certain element repeated set is not changed, certain element repeated set is not changed. Certain element Here is 3, but here is 3, 3. Not changed. 3, 3. Just 3, 3. Here is 7, 7. 5, 5. Okay? It can be repeated. So if you can see this type of set, we can write equivalent set. So we have learned equal set and equivalent set. Let's come to the next topic. Okay, let's come to the another point, Venn diagram. This is also related to set. Okay, Venn diagram. Venn is a person. Who is Venn? John Venn, 1834 to 1883, introduced the method expressing the sets by diagram. George Cantor invented set and set builder method and tabular method, but John Venn invented Venn diagram. He has shown set using diagram. So this diagram is called the Venn diagram. This diagram is called the Venn diagram. So Venn diagram generally rectangular and circular region. Rectangular and circular. This is the rectangular. If we think that these are the sets included in capital U, you can see the big U. So this is the universal set. And you can see I have written here another diagram. Here is the A and here is B. A and B are two sets. A and B are two sets. And this is, here is A. A is a set and B is another set. A and B cut each other, one common point. So what is the name of the common point? What is the name of common point? A intersection B. This is the A intersection B. So this is A intersection B. So what is the name of this part? You can see what is the name of this part. You can see the board again. So come back here. You can see what is the name of this part. In A, set of A, this is A. This is A cut by this part, cut by B. So it will be A difference of B. A difference of B. Again, the set of B. This part cut by A. This part cut by A. So this name will be, this part name will be B difference of A. B difference of A. Am I clear? These are the Venn diagram. So if we see the diagram, here is A, here is B. This is A, this is B. A and B are disjoint. A and B are disjoint. And this is A intersection of B. This part is A intersection B. And this is A difference of B. And this is B difference of A. Okay? So these are the Venn diagram. A intersection of B. And you have to write here universal set. You have to write here universal set. Let's come to the point. We have to prove that if A difference of B, B difference of A, and A intersection of B are disjoint sets prove that cardinal is called cardinal, or you can say n of A union of B equal to n of A plus n of B this is a proposition. We have to prove the proposition using Venn diagram. We have to prove that. This is a very important proposition. Before prove this proposition, you have to write the same way. Prove the proposition. Let A difference of B, B difference of A, and A intersection B are disjoint sets. Disjoint sets. So we have to draw a Venn diagram. We have to draw a Venn diagram in this way. This is universal set, and this is the set of A, and this is the set of B. So you can take the pencil compass, then figure will be accurate. So this is a set of A, this is set of B, and already I have shown you few minutes ago this is A cut by B, cut by this part cut by B, so it will be A difference of B. So A difference of B, I think you can see A difference of B, and this part will be B difference of A, B difference of A, and this is the common part. This is the common part of set A and set B. This is the common part. This is A intersection of B, A intersection of B. Now A equal to what? A equal to what? You can see in the figure, we know the union means common and uncommon both. Common and uncommon both. So union, that is as like as a conjunction, and or but, this type of thing. Okay, so in A, in the figure A, we can see here is A difference of B, and here is A intersection of B. So A equal to, you can say here, A difference of B union A intersection B. So already we have done set A completed. Now come back the set B, set B. So if we draw the figure B, so we can see this. So I think you can see here, this part cut by A, this part cut by A. So this is A intersection B, and this is B difference of A, B difference of A. So here is B difference of A union of A intersection of B, A intersection of B. Again, I think you can say A equal to A difference of B union of A intersection B, and B equal to B difference of A union A intersection of B. We have to prove that, you can see we have to prove that cardinal of A union B equal to n of A plus n of B minus n of A intersection of B. We have to prove that. This is our main question. This is the main question. Already we have got A and B, but you can see here is A union B. So you have to find out A union B. We have no need to figure just now. So after completing this, we have to go back to the calculation. We have to find out A union B. I think you have got it in set A. In set A equal to this and set B equal to this. So please come back. So A union of B. Union means common and uncommon both. Common and uncommon both. So common here is this and this are common part, and this and this are uncommon part. So you have to write A difference of B union B difference of A union A intersection of B. Intersection of B. So we have to prove that n of A union B. Be careful, this is the cardinal number or number of elements. We call cardinal number. Okay? So after completing this line, we have to use n. So if we use n, replacing union we have to use plus. Replacing union we have to use plus. So therefore n of A, here is A. After completing this line, you have to write n of A equal to n of A difference of B plus n of A intersection of B. This is number 1. So already we have got n of A. Why n of A? Because this equal to n of A plus n of B minus n of A intersection B. Why we have to find out n of A? Because here is n of A. So from this line we have got n of A. Replacing union we have to use plus. So A done. Done. Now B, n of B. Therefore n of B equal to replacing union we have to use plus symbol. You have to use plus symbol. Please follow the board. We can see the right cardinal of, or you can say n of this plus n of A intersection of B. N of A intersection of B. This is number 2. This is number 2. So A and B completed. A and B done. Now here is n of A union B. N of A union B. So therefore n of A union B equal to, what will be? You have to use this line. N of A union B equal to, just here is use n of A intersection B. Here is plus n of B, n of A difference of B plus n of B difference of A. Here is plus n of A intersection of B. I think already we have got the model of n of A union B, cardinal of A union of B. You can say n of A union B. Already we have got n of A union B, and we have to find out n of A, n of b, n of a intersection of b. So this is number 3. This is number 3. So if we can find out the value of this and this, already we can prove the proposition. So n of a difference of b we will get from 1. We will get from 1. So you can write from 1 we get. From 1 we get. What do we have to do? We have to find the value of n of a difference of b. N of a difference of b. So n of a difference of b is here. So if we keep this, if we transfer, we get n of a difference of b equal to we will get, here is plus, so if we transfer we will get n of a intersection of b, 1 2 3. So we can use number 4. So already we have got the values of n of a difference of b. We have got n of a difference of b. So what do we have to do? We have to find out n of b difference of a. N of b difference of a. So b difference of a we will get from 2. We will get from 2. So what is the b difference of a? B difference of a is here. So from 2 we get, n of b difference of a equal to, b difference of a equal to what? Keep b difference of a, so this part will be subtracted. So we get n of b subtracted n of a intersection of b. This is number 5. This is number 5. Already we have got the equation 1, 2 and 3. Equation 1, 2 and 3. 3 is the main equation here. 3 is the vital part, because 3 is as like as our proposition. So in 3, putting the values of this and this in equation 3. So if we replace this part and this part, we will get main proposition. Okay, let's come back here. So 1 and 2 completed. Now come back. Putting the values of in 3 we get. In 3 we get. Which one is 3? This is the 3. This is the 3. So 3 is n of a union of b equal to, n of a union b equal to, you can see here, putting the values of this, values of n of a difference of b equal to, we will get this. Just write here n of a minus n of a intersection of b. So putting the values of this completed. Now you have to putting the values of this. We will get from 5 n of b difference of n of a intersection of b, and here is the remaining part is this. Remaining part is this. So write down remaining part n of a intersection of b. Intersection part. Okay. So putting the value has done. Now we have to calculate a little bit. So 3, 4, 5. So from 3, putting the values of this, from 4, putting the values of this here, and putting the values of this here, and this is the remaining part. Now putting the value completed. So you can see here same thing. N of A intersection B, this is minus, and this is also minus. So minus and plus cut. Therefore we get N of A union of B equal to N of A plus N of B, N of A intersection of B. So follow the board, just putting the values of this and this in 3, we will get this line. Here is plus N of A intersection B, here is minus of N of A intersection of B. So cut it, we will get N of A union of B. N of A union of B. Be careful when you solve the maths about union and intersection. Be careful. So N of A union B equal to N of A, N of B minus N of A intersection of B. Okay, I think you have got the proposition. So next time we'll do another proposition. Just we'll do in the next time. N of A union B union C equal to, we have to prove that N of A, N of B plus N of C, difference of N of A intersection B minus N of B intersection C minus N of C intersection of A plus N of A intersection B intersection C. Using this proposition, we have to prove this proposition. Okay. So next time we will prove this. Then we will start our next topic in maths. We have to do some maths. So when you solve the maths in this exercise, always you have to put your main focus in union and intersection. Okay, thank you very much.